Don't forget to like and subscribe. It's Jim Keller, everybody.
And welcome to the Tech Poutine, one of your stops for many semiconductor things. I'm Ian from All and More. Joining me is George from Chips and Cheese. And we've been here, there, and everywhere the last few weeks, if you hadn't gathered, by the irregular nature of the Poutines.
Fudging busy.
4 weeks out of the last 6.
Yeah.
And there's still some more to come, especially through to the end of the year. And
yes, this is something ramped up really quickly this year.
And rather than spend a little while ramping up, we're going to actually have to jump straight into it because I have a hard stop in a little bit. So let's go over to our headline topic of the day. Let me just re-enable comments for a second.
Hey, Ian.
Yep.
You got the title wrong. It's not the 10th, it's the 9th. For the YouTube video.
Half of my... yeah, no, you're right. It's been
a very, very long...
I got the time wrong by 2 hours because it's 19:30, not 9:30. I got the date wrong because it's 9th of October, not the 10th of So
yeah, it's been a very long few weeks.
Let's see if I can edit this. I can at least edit it on YouTube. Okay. Unfortunately, linked here. Does LinkedIn even let you change titles? Oh, I didn't put the
date there.
It's because you only have 75 characters.
Ha! Nice.
So let's go straight into the first news of the day. Everybody's trying to make money. This is the announcement between AMD and OpenAI. So at a similar time where NVIDIA is announcing $100 billion investment into OpenAI, they're going to be buying anywhere from $100 to $200 billion worth of GPUs from AMD. So the money from NVIDIA
is going to AMD in a very roundabout way.
The agreement never expressly announced that OpenAI had to buy NVIDIA GPUs with that money. So, yep, there's that. But this agreement, if you hadn't read my post already over at the More Than More Substack, I will drop a link in the comments just in case. It was announced that AMD would sell 6 gigawatts of AI GPUs to OpenAI over the next 5 years, starting with 1 gigawatt of MI450 in the second half of next year. And as some form of deal, OpenAI would gain equity in AMD in stages based on both OpenAI's deployment of AMD and AMD's share price. So it starts with the first gigawatt. From that, OpenAI will get to acquire newly issued shares at 1 cent per share, so nominal value. We'll start with the first gigawatt. Presumably, that means that there will be more stages as more and more gigawatts deployed through this agreement. But there's also the tie into AMD's share price. AMD's share price before this announced was $165. And after the announcement, it rose to $225. I believe it's probably around the 220 mark now.
I thought it was like 233.
It went, as with all these things, everybody hits the hype, and it went down a bit. Yeah, okay, it's at 231 now.
231, okay.
Yeah, and it did. So it went down, then it went back up. So it hit a peak of about 240. But at the end of this, if all 6 gigawatts deployed, AMD hits $600 per share. So,
ow. Your mic just went bananas. Ow.
oh, sorry. $600 per share and 6 gigawatts, assuming AMD's outstanding share number stays relatively same, this would make AMD almost $1 trillion company. So there is incentive for OpenAI to improve AMD's business acumen and reputation on the street to making the company more valuable. All in all, these shares, if they were acquired by OpenAI at the time of issue, and then sold at the end of the 5 years, once AMD hits $600, once all 6 gigawatts are being deployed, this would be a $96 billion ownership for OpenAI, which they could sell straight away, and it would almost pay for all the GPUs, supposedly. So the big word on the street is NVIDIA can sell GPUs hand over fist, no problem, to the point where they're even investing in the companies buying the GPUs. AMD has to sell the GPUs, but offer equity in exchange for buying them and performance goals. And if all the performance goals are hit, the GPUs are essentially free. The thing is, a lot of people misread that and said, oh, this is OpenAI getting GPUs for free. No, OpenAI still has to spend at least 100, if not $200 billion to deploy all of this. There's also an argument of, well, where is OpenAI getting the money? The answer is NVIDIA. And the answer is OpenAI going to be profitable ever? I mean, don't get me wrong, they're making money, but they're spending way, way more on infrastructure rollout and partnerships. Now, these GPUs, these 6 gigawatts, don't have to be bought by OpenAI directly. They can be bought by OpenAI partners.
Like Microsoft.
But have to be like Microsoft, but have to be used for OpenAI.
Yep.
That being said, these GPUs won't be part of the Stargate project because that's NVIDIA.
Is it all NVIDIA?
Yep. It's meant to be all NVIDIA. So this is additional to that. The Eagle supercomputer is
Microsoft?
part of at Microsoft is part of an OpenAI deployment.
That doesn't shock me.
And we don't know how many GPUs are in that. But suffice to say,
we know the part that Eagle announced.
Yeah. But it's the whole point being is this AMD is coalescing the hyperscalers under one customer, or at least this customer, in such a way to drive sales. Lisa has been a vocal proponent of AMD's AI revenue reaching tens of billions per year by the end of the decade, right?
Well, arguably, they've just hit that.
Well, so for reference, they sold $5 billion last fiscal year of AI hardware. And this year, they were meant to be around about 7 based on estimates. However, some of that was meant to due for China, which they obviously can't sell, or all that is happening as well. So they're more likely going to be 6 and a bit this year. So they were initially, numbers I saw from Morgan Stanley, they were predicted a 40% increase in sales in AI hardware this year. NVIDIA were predicted a 60% increase. So AMD is losing market share on a 40% gain, which is really stupid.
The weird world that we live in.
So yeah, the short and curlies of the
Hey, by the way, I'll be down in San Diego in the not too distant future, probably next week. If you want to meet up, I'll DM you that. If you check chat, Hot Isle just sent me an email.
Oh, Well, yeah.
So, yeah.
It's when you read something, you have to speak it out so everybody knows what you're referring to. I was like, wait,
yes. Sorry. Hot Isle, a provider of AMD GPUs, ironically enough, apparently has a MI355 box for us to play with for a little bit.
Oh,
So
nice.
That will be very fun to test. And Zachary, yes, I should be at PBX land, but life is life. And
it's we can go into deeper details of the article. Yeah, so the short and curlies of it is just simply AMD has AMD and OpenAI have signed an agreement for up to 6 gigawatts of GPU sales, with the first gigawatt guaranteed with for the end of 26. The revenue will be recognized at the end of 26. And if OpenAI or its partners buy the other 5 gigawatts over the next 5 years, and AMD's share price hits certain targets along the way, OpenAI could stand to gain 10% of AMD at a nominal cost, which, if sold at the end, if it hits all the targets, could essentially pay for the GPUs. It depends on where exactly you put the power of an AMD GPU during that time, because gigawatts is the weird metric that data centers run in, right?
Yeah. Well,
right.
watts being the base unit, and then data centers are up to megawatts.
I know,
or gigawatts. But the facility can provide that.
But from the other side, we speak about either flops, units,
yes,
or racks or whatever.
Yeah, we talk in compute; they talk in power.
So if you're looking at 2 kilowatts per chip, which might be an average between now and the end of the decade, that would be 200,000.
I guarantee you we're going to be hitting 10,000 watts per package by the end of the decade.
Now, do you count that as one GPU, or are you doing it as
NVIDIA's
4 GPUs?
The question is, can it access all of the memory on board?
Well, I mean, the point is, if you try and do the mathematics and try and work out the cost per chip, a mid to low estimate would be about $90 billion for 6 gigawatts. A high end estimate would be 180. And the value of the shares, if they were to fully vest, would be 96. So there is that. Now, people have been asking me about power, because 6 gigawatts doesn't come for free. You have to build it.
For the record, the U.S. power grid at peak can do about 760 gigawatts. So 6 gigawatts is
1%.
Not even a rounding error. Like 1% is a rounding error.
Lost in the margins due to some bird on the power line.
Absolutely. Yeah.
It's the I mean, so one thing to note here is power stations will sometimes be quoted in terawatt hours per year. And the key conversion here is 1 gigawatt is about 6.7 terawatt hours per year. So if you see something scary like 374 terawatt hours per year in AI by 2030, if you do the math, that's only 60 gigawatts. Anyway, one of the conversations here is about power and actually having the power. And for me, I've said this before on Poutine, I think it's more of a question of power delivery, right?
Yes.
So this is a post that I think I've referenced before, but I've actually pasted it here, from Guido Appenzello, who he's been many things, CTO at Intel VMware. He was the person who first introduced us to Intel's custom IPUs, Mount Evans. And so, in terms of energy, it's these bullet points here. Right? NVIDIA will ship about 6 million AI cards this year, 25. If you average 1 kilowatt, some will be more, some will be less. That's 6 gigawatts. overhead for the infrastructure, 50%, so that's 9 gigawatts.
Mm-hmm.
That's all NVIDIA make in this year. China in 1 month installed 90 gigawatts of solar.
Mm-hmm.
So now China has a massive incentive scheme to install solar. In the US, it's obviously more focused on fossil fuels and nuclear. So the solar industry doesn't have, also all the manufacturing's in China, so costs are low. China has a ton of space. So it's not so much a question of generation, it's the economics of generation, the economics of installation. But beyond that, right? And here's a solar farm in China. Beyond that, it's more of a case of power conversion, the substations, the batteries, the supercapacitors, the backup systems, and all of that. And there's other articles here have been showing this more than I have. The transformer lead times, the grid approvals, substation build-outs, that's all pretty much reserved for the next few years.
Yeah, I think that's been reserved for the next 5 years.
And that's
in comparison,
very slow market.
So in some regards, tech can be very fast and tech can be very slow. This is more like building an architecture, like a ground-up architecture, than it is building out a data center, which is...
Well, it's just simply
building a data center. Like
it's not even that. It's not even that. It's build a substation.
Yes, takes a long time.
Right? You might think, well, that could be a prefab unit, and you're right, it could, but there's still a ton of work that goes into it.
Yeah.
So yeah, it's all about generation is relatively okay. It's all about delivery and conversion.
Brian V, the largest nuclear plant in the U.S. is 4.6 gigawatts base power supply to the grid. Speaking of,
so Mr. Viptis says they turned on 90 gigawatts in a month, but it took a long time to build that much. Yeah, I'm not saying that's a monthly figure. I'm just saying it can be done. A 10x can be done.
Yeah.
Right. Now, okay, 9 gigawatts is just NVIDIA. You add in the AMD, you add in the Cerebras, you add in everybody other stuff. Even if you doubled that number, now there's not enough of that cost to go around. But it's that sort of thing.
Yeah. And yeah, so actually a little bit of a tangent, but a new nuclear company is saying that they're going to be able to start producing essentially 50 megawatt pods for data centers by, I think, 2030. Again,
which is too slow.
Yeah.
It's was it one of Musk's data centers has 110 diesel generators?
Yeah.
So that's just burning diesel.
Mm-hmm.
Don't ask Jensen what his clean energy strategy, his net zero thing is. So yeah. TSMC outputs 12 million wafers a year. It's about 4 million a quarter. And last time I did the math, which is probably 2023, just under 1 million of those were 7 nanometer and below. So 11 million out of the 12 million are legacy, right? It's, even though it's 50% of the revenue, it's 90%, 92% of the production.
Yeah.
And so, so even if you said 600,000 wafers, the equivalent of 5 Blackwells a wafer, if you add in yield, die sizes and whatever, and even were quite harsh, that's 3 million chips, 3 million AI chips at 1 kilowatt a piece. So,
Mm-hmm.
yeah, you can roughly make these numbers out. I've got the exact numbers somewhere in my databases.
Owen, H100s are already being rotated out as legacy.
I mean,
yeah, we've hit the point where, I mean, A100s came out, what, half a decade ago?
6, maybe.
6 years, like 5-6 years ago.
Well, so Owen says, will we eventually hit a point where A100s and H100s start getting rotated out as they become legacy hardware? The demand is so high, people are buying H100s because they can't get Blackwells. And all they're going to do is install the Blackwell right next door to the Hopper.
Yeah.
Right. It's Jensen's argument is, so you can't buy everything you need. Well, that's okay. You buy some now, and you buy some next year, and you buy some the year after, and you just continue increasing your build out, and you just get what the latest is at the time.
Yeah.
It's funny enough, supply chain's massive. I'm even speaking to freight companies about deploying some of this stuff. So it's one thing to note here is this agreement is heavily assisted by AMD's acquisitions this year and last year. People like Silo AI and Nod AI on the software side. I mean, you've met with Anush. And spoken to him, the head of the AI software side. The ZT Systems acquisition. I mean, if I can go back to this article, I mean, it's Helios, their rack scale system using Zen 6, MI450, and then the 2027 rack scale system. Chances are we'll see all of this. So funny thing. On Twitter this morning, I posted a tweet from an email I got saying, hey, do you agree to the embargo on October 9th? They sent it to me 9 p.m. on October 8th. So 3 hours for the embargo. Silly,
I had a company send me.
I haven't finished yet.
Okay.
And then they said, oh, we're posting at 9 a.m., but you're free to post at any time that day. And, by 9 a.m. or 9 p.m., I'd obviously logged off, so I only saw it this morning. That was a press release saying that Microsoft are offering GB300 instances on Azure Cloud, the HD V6 or whatever it is. And they said, we will be offering 4,600 NVL72s. See if I can get the right wording here, because the right wording is ridiculously stupid. Today, Microsoft will launch Azure's first virtual machine series, the NDV6 GB300 virtual machines, delivering the first at-scale production cluster with 4,600 NVIDIA GB300 NVL72. That sounds like 4,600 racks.
Yes.
Which would be, people are saying, roughly $3 million a rack. That'd be a $12 billion installation.
Yeah,
It turns out, and I asked for confirmation. I said, is that 4,600 GPUs or is that 4,600 racks, i.e. 300,000
Let me guess,
GPUs?
It was 64 racks.
Yep. It was just 64 racks.
Yep.
So,
yep. I'm like, 4,600 goes into, or 4,808 goes into 72 suspiciously well.
Yes. Yeah. And I'm not saying 60 installing 64 racks is a big achievement, sure, but 64 regular racks wouldn't be. 64 120 kilowatt racks would be. And Mr. Viptis says 3,600 racks equals 1 GPU. I didn't go into details about how many GPU dies on a chip and whether they were counting that. But yeah, it's they sent and the picture of the systems they sent over was a close-up of one NVL72.
Of course.
And I mean, like, if you had 4600, you'd have a really badass image.
Very true.
Our good friend Felix actually was just at the Aurora supercomputer.
Oh, was he?
In Argonne. He posted a picture on Twitter. But well, no, okay. He recently posted a picture on Twitter. That's not to say he's there right now.
Okay, I see what you mean.
He has at some point visited the big Intel supercomputer.
I wanted to go visit LCAP, but just the timing didn't work.
Yeah. So in terms of the AMD news, I mean, it's a substantial win for AMD, right? This is an instance of OpenAI buying AMD hardware, selling for a reason other than we can't get NVIDIA, which is a battle in this industry. You don't want the reason your hardware is being purchased is simply because your competitor is sold out. That's not a growth vector in sales. However, OpenAI has been a proponent of, well, AMD optimized for inference is quicker than NVIDIA for us. They said it with the MI300 series, the MI300X. It was 10% better TCO on AMD. And if you're running at the scale that OpenAI is,
10%
that's
is a
millions. Lot. Yeah, is a lot. I mean, you're still spending 10 times that amount, but so yeah, it's an important message for AMD, and it does mean that if all this hardware gets sold, that's tens of $billions in the bank account, and share price go to the moon, and investors will be happy, and won't somebody please think of their shareholders? And gaming will become just a bug smear on the Windows Shield.
Already has.
Already has, yes. Concur.
Let's be honest here. It already has.
Concur. So that's our first topic. Our second topic is going to be a big one, so I'm just going to run a mid-roll right now, if that's all right. It's we don't actually have a sponsor for this episode, but we are thinking about one or two who have approached us. But for now, you just get me and George talking about ways that you can support what we do. You can head on over to our respective channels here on YouTube. You're already here, so you know what my channel is. Go over see George's channel over at Chips and Cheese. George, you have some shilling to do.
Yes. So, while this does directly tie into our next topic, I had a chance to interview Stephen Robinson of Intel, who was formerly the head of architecture for eCores and is now the lead architect for all x86 cores at Intel. That was a great interview that went live today. And I did it. We have a video on Panther Lake coming along with an article, but I decided to do the interview first. I kind of want y'all's opinion on that. I don't know how to feel about that, but I thought that the interview was more. There were some details in there that folks would enjoy that weren't in the slides. So,
I'll just bring it up. Head on, and here we go. Head on over to YouTube. You're already here. Bookmark it to watch it later. But this is the interview with Stephen Robertson. He seemed pretty calm at the event. Just doing his thing.
Yeah.
I mean, aside from the people who almost got thrown out, but we'll leave that for different conversations.
Yeah.
Didn't some of the stuff get leaked? Because
no, actually, surprisingly enough, a lot of it was not leaked. which is
Mm.
honestly kind of surprising. They were actually very strict about not recording in the media room where they were giving the presentations. There was an embargo date leak, but that was an accident. Somebody was taking a picture of their badge in the room when it flashed up, not realizing that that was in the picture of their
Not
badge.
realizing.
No, apparently it was an actual mistake by somebody.
Yeah. Actual mistakes don't happen. It's people who...
Patrick, I thought it was a nice Patrick says, I thought it was a nice interview. I thought it was your best one yet, George. Well, thank you. It was my latest. So I guess I've been improving.
It's well, you also good. Looks like you got a quiet area as well.
Yes. Also, Dean, I'm fine either way. I do think that would be useful to have a breakdown of what Panther Lake is first and what does it look like. That way you can point out things you have noticed. Yes, the thing is that everybody was already doing that. Like, you could go to a different site and get that. I felt like this was a little bit more in depth and more to the CNC audience, but that maybe I'm wrong there. I don't know.
It's when you've only got 15 minutes, or realistically, you're actually recording for about 20, 25,
Mhm.
and also set up either side. You got to
Yes.
think, well, what do I speak to this person about? And spending the first 5 minutes doing a recap. You got to think, how much is that worth it versus another 5 minutes of actually hard-hitting questions or informative questions?
Fun fact, I made up every single question on the spot. I had a general idea of where I was going, and I made it up as I went along. Anyway, I'll if you guys want to watch, Ian hopefully posted the link in the chat.
Yep.
But yeah, I think from there we should probably move on to ITT itself.
Yes, and let me just double check that I have a. Yeah. Okay.
They have all the PDFs, or at least the links to the PDFs, so that you can access them if needed.
No.
Cool.
It's all good.
Cool.
It's
okay.
we're trying to be more talky.
Okay.
So it's just so you're aware, Karehaqt said no, not that one. It jumped on me. All this money wasted on AI just to generate slop. One of the biggest use cases for AI right now is building chips. Every chip in modern devices has had some form of AI used to generate it now.
So fun fact.
Or AI used in the validation, AI used in the testing. We're not talking about automated algorithmic suites. We are literally talking about transformer models.
So apparently AMD was using what you could call agentic AI back in the 80s when they were doing fabrication and sort of improving their fabrication process. That was a published story. Yeah.
Yeah, no. I mean, that's like a feedback loop, and that's more like a perceptron type stuff. If we're talking about things like attention and whatever,
the
EDA has a weird history with the phrase AI.
Yes, it does.
But yeah, it's
languages anyway.
Big topics right now, aside from let's identify people or a cat or whatever. Or generate AI slop is code generation. And I'm not talking about vibe coding in the vibe sense. I'm talking about vibe coding in the coding sense, which is the sort of crap I do. Yeah, sure, 85% of my code is AI generated, but it's the dull 85%, and I still need to spend time fixing it. But I still write twice as many lines of code with it as an assistant than I would do natively, because do I really want to program a recursive HTML table? No. So yeah, it's one of the events in the past week that I did is Intel asked me to present to their AI business unit. I'm talking 10,000 people.
Mhm.
Purely an internal discussion, so I can't say much about what was discussed. But I was asked, and a very relevant question is, where is AI going? What's the killer app, right? I said in the next 12 to 18 months, and I'm saying this to all my clients as well, in the next 12 to 18 months, the ability for an AI system to generate code. We're talking, you can have a six word input to generate 100,000 token output, or you can have a 6 word input and a code base of 100,000 lines as a code prompt to generate, to generate the code you need. Because it's not only generating the code in front of you, it might also be changing a header file here and another library over there and another library over there. So you also need large context length for those sort of commands, but then you also need maybe up to 2,000 tokens per second, because you're not going to sit around at 20 tokens per second while your function that you're working on in this file changes, but also a lot of the other files that need to change also change. So it's coding can be very prolific if done right. And I've got a feeling that is something that companies will pay for.
So mayhaps. I don't know the future. I don't have a good crystal ball. What I do know is ITT happened.
Yes.
So
set up the premise for us, George.
Yeah. So Intel Tech Tour is an event that happens every year. In prior years, it was in Malaysia. Last year was in Taipei. This year it was in Arizona.
They've also done one in Israel.
Yep. One in Israel.
Before everything went down.
Yeah.
Sorry, Circuit gives us a super chat for $10. 2,000 Chuck E. Cheese tokens a second. That's a lot of games you can play with that system. After the Altera thing last week, which also happened, I took Ryan to Dave & Buster's.
Ah, nice.
And we just played pool.
Nice.
So, but yeah, thanks for that. Sorry, George. Yeah. ITT premise.
Yeah. So at ITT, Intel gave details about their upcoming Panther Lake client SoCs, some performance numbers for Clearwater Forrest, and announced that 18A is in high volume production at Fab 52, which I did get to go see. And I had to put on the bodysuit. Yes, I had to put on the bodysuit, everything, and that was fun. So,
well, it was what, 200 and something press and analysts.
Yes.
All flew out to Phoenix, to Ocotillo, and yeah, the whole purpose was 2.5 days. Half a day of fab.
No, it was 5 to 6 days.
Well, if you include all the travel and you waiting around, I was on the ground less than 48 hours.
Yeah, because you left.
Yeah, and yeah, so think about it: half a day for like a fab tour and a chance to go around the Ocotillo campus. And so George, yes, he got to put on a bodysuit. And I was actually looking for a video I did when I visited. I can't type properly.
So, Jay, remind us what qualifies as 18A, and he qualifies that statement with, i.e., what UARTs are being created with that. So, I was about to get on there, but
this is the video I made. That's not part of my video. That's somebody else's video.
Yeah.
This is my video, and it's the link to the Reddit post. But yeah,
that's still the Reddit post.
if you want to know what a bunny suit is, it's not the thing that the Playboy models wear. It's a semiconductor clean room.
Yeah.
Yeah, if you try and ask GPT for a Pope in a bunny suit outfit, it rejects more to the bunny suit than the Pope.
That's funny.
So, I mean, George and I were both there, along with Jeff from Craft Computing and Patrick from Serve the Home, and all your other fellow content creators and traditional press as well. The first thing I did is I landed and went straight into a meeting. Pretty much, they had some analyst meetings, but my first day was the fab tour, and it was one of the shortest fab tours I've been on. We actually went inside Fab 52, which is where 18A is being made. It started off with a drive around the campus, around the Ocotillo campus. So this is Fab 2, Fab 12, Fab 22, Fab 32, Fab 42, Fab 52.
No, Fab 12, 22, 32, 42, and 52. There's no Fab 12 there.
You just said 12.
Yeah, no, I said there's no Fab 2 there.
So there was Fab 2 there. That's my point.
That was over in Chandler, not Ocotillo. Sorry, that was over in the other campus there. Not Ocotillo. Ocotillo was 12, not 2.
But that's
packaging.
That's because it used to all be essentially the same. It was considered the same site internally, and it's called Fab 2 because it's the second fab.
Yes,
that's literally it. So, all the Israel fabs are Fab 7s,
something like that. Yeah,
yeah. So it's and then they just iterate in 10s because they don't think there'll be more than 10 based sites, which is whatever. And yeah, so we got a tour of we literally sat on the bus and did the external, ring road tour. And I'm sure our tour guide had been given the tour the day before because he didn't really know much. He pointed out the power reclamation plant and
the water reclamation plant. The water reclamation plant, yeah.
And we asked questions about the power, and he had some answers, but not many.
So I was, fun fact, I was yelled at by putting ASML EUV machine in my notes. I couldn't put ASML in my notes, despite them being the only manufacturer of EUV machines.
So it's when you go into, the buildings are practically empty. And that may have been because of the tour. They told everybody to go home. The fab was still running. And we went in, we donned our bunny suit, and then we got a short tour from one end of the fab to the other. And I think it was also the short axis as well. At least it felt like it was the short axis. And which was, I don't know, 15 minutes max, 20?
Yeah.
And if you've never been in a clean room before, half of it's bathed in yellow light in order to stop photolithography happening accidentally. There's also, it's cleaner than an operating theater. There is a laminate airflow top to bottom in order to keep dust going off, and everybody is also mask and shade and everything else. And whenever I've done previous tours, especially big group tours, they tend to put stickers over all the machines, the names, the models, so you can't tell whose machine it is or what it's doing, or which is funny because that's why George got shouted at. Because they did. The thing is, it's full of Nikon and Lam and Applied Materials and Zeiss and all these sorts of things. All these labels are everywhere. Our tour guide didn't really tell us what any of the machines are doing. Partly because he was in front of us, walking forward, speaking forward, so nobody could hear him. Which
our guide was good. She stopped and talked.
Oh, okay. So they just screwed up the first set of analysts. Because you were one of the last groups in, weren't you? You were on the Wednesday.
I I was actually, I think, the final part of the final group to go in.
Yeah, whereas I was the first group to go in.
Yep.
Yeah, and you can't take cameras, obviously, because it's a clean room, or you need special permission. You can't take pens, you can't take pencils. They give you a special vinyl book,
Mm-hmm.
and you, I mean, I've got a couple up there, but it's as a souvenir to take home. So the idea being that if the as you get shown around, you can take notes and, you know, oh, this Nikon machine, oh, this, you know, machine. Latex, not vinyl, sorry. The best way to experience that paper is using a ballpoint pen right on a banana. It is the smoothest experience of writing, and writing on a banana has exactly the same effect.
So I'll do this later, but I'm going to test some of my fountain pens on this paper and see what it feels like.
So it's designed to be non-absorbent, right? Because you don't want, it's the paper fibers. You don't want the paper fibers in the air.
So you're saying that this is not going to work very well.
I'm saying a small amount will absorb, but it will probably run off. But yeah, and it was let's walk down to the end, see a couple of EUV machines. They also had spots for a couple more EUV machines in the area they showed us. You know, just literally gaps. And the idea is that a lot of this is prefabbed. The idea being that the minute you put it in, all the pipes line up to the sub-fab underneath, and the power delivery and the chemical delivery underneath. And the idea is it's all meant to be straightforward. You know, they've got crane hoists above because these machines take so long to install and they're so heavy, compared to normal machines. Yeah, and then came back out and some photos were taken, and that's about it. So, that's
actually, it works pretty well.
Unfortunately, you have chicken scratch for handwriting.
You're not wrong, but ouch. That hurts. That hurts.
You couldn't even do cursive.
I can. Just, I hate doing it. I can read cursive.
You need to flail an old woman in advance. Is that what you're saying?
So I used to have, so my grandmother used to all write in cursive, so I could read cursive. I still can. Also, thank you, Vince. A doctor complaining about writing?
My writing is perfectly legible when I try. It's okay. So that for me was day one. Day two was consumer.
Mm-hmm.
And part of day one was also Foundry.
Yeah,
just in general.
Day one was like general Intel, and then Foundry.
Because Foundry, these Intel Tech Tours are typically a product event where we go to see Foundry stuff. So Foundry get like a couple of hours to shoot their shot. And we got more insights into 18A, which is their first gate-all-around backside power delivery enabled process node. Intel is the first to gate-all-around technology in the ecosystem, just like they were first to FinFET. And it was Reuters has been on a tear of late, complaining about Intel 18A yield, which is not borne out by the metrics. Now, unfortunately, I kind of have to shut up a bit here because I know too much about the process node that I can't share, but yields are good. Intel is still working out on what a good PDK looks like for its customers. 18A isn't one that's going to be used much externally. It is being tried by a few. Realistically, it's
That-
18AP, which is like the next one in the family. Instead of 18AP, they perhaps should have called it 17.
So
Um,
yes, correction. Samsung was actually the first to GAA FET. Thank you, DKR.
No, well, IBM was technically first to GAA FET.
No, in terms of product, Samsung is currently shipping the latest Samsung watch on their 3-nanometer GAA FET product.
Okay.
So technically, they were
yes,
they were
we don't care
shipping
about
first. Technically,
we don't care about that. But this is Intel's first GAA,
yes.
and it's ahead of TSMC's in terms of timing. They have promised somewhere in the region of 10 to 15% better performance over previous nodes.
15% performance ISO power, 25% less power ISO performance. In performance is usually frequency in this case, and 1.3x chip density. So that's not a shrinkage. That's not a comparison of the logic shrink. That's a total chip density number, which is different than a logic shrink or the
Yes, it depends how much SRAM is in your representative design, which because I believe Intel at IEDM last year, or ISSE last year, showcased that DS backside power delivery doesn't make sense for SRAM.
I could believe that, yeah.
And so you don't get the same shrink due to things like backside power delivery. And the first two products to be built on 18A is Panther Lake and Clearwater Forest.
Mm-hmm.
And so the first proper Intel Products Day was Panther Lake. All about Panther, all about consumer. George, do you want to take over? Take this?
Yeah. Starting with Panther Lake. If I say PTL, I mean Panther Lake. That's just the acronym for it. Panther Lake is going to have 4 Cougar Cove cores as their P-core, 8 Darkmont cores as their E-core, and 4 Darkmont LPE cores. The difference between the LPE cores and the E-cores is that the LPE cores do not have access to the CPU L3. They do have access to the 8 megabytes of memory side cache, but not to the CPU L3. PTL will also have an Xe3 iGPU, and there's 2 different dies of that. One version is a 4-core or 4 Xe core fabbed on Intel 3, which will make this the first Intel Arc product fabbed on Intel 3-nanometer. And there will be a second version of the iGPU with 12 Xe3 cores fabbed on TSMC N3E. Intel did not give clocks for anything here. However, if you do the reverse calculation from the TOPS number, you can get the clock speed of the 12 Xe tile GPU, and it's clocking at about 2.5 gigahertz, which is pretty high. Now, I have to rant about 2 things here. One, Intel, for the love of God, stop giving us dimensionless graphs. Put numbers on your graphs, please. Don't just have a dimensionless line. Don't do that. Give me a number, please. Give me numbers on your axes. Secondly, Intel decided to do a very what's he doing here? Intel decided.
Ignore me. Just keep going.
Okay, so Intel decided to call the iGPU on Panther Lake part of the B series, similar to Battle Mage, despite this using Xe3, which is not confusing at all. And even Tap or Tom Peterson said that this was not a great move. So yeah, even internally, it's not people's favorite. Anyway, moving on to what Ian is typing here. There are 3 SKUs, or 3 types of SKUs, I should say. Basically, 2 compute dies. All SKUs have 4 Cougar Cove cores. The smallest of these, which is known as 404, that's what I'll refer to as, has 4 Cougar Cove cores and then 4 LPE cores. No E cores on the CPU L3. The larger compute die, also known as 484, has 4 Cougar Cove cores and then 8 Darkmont cores on the CPU L3, and then the 4 LPE cores. That is the major difference here. Now, the performance numbers here, yeah.
Just keep going.
Okay.
I'm putting stats on the screen.
Okay. So to give you the performance numbers, 10% faster single thread than Lunar Lake at the same power or at similar power. 50% more multi-thread performance compared to Lunar Lake, again at similar power. 30% lower power than Arrow Lake at the same multi-threaded performance. 50% more GPU performance at higher power compared to Arrow Lake and Lunar Lake. 10% lower power than Lunar Lake. 40% lower power than Arrow Lake, and the same NPU tops, but the NPU has been made 40% smaller for more area for other things. So yes. Now, Cougar Cove and Darkmont are iterative on the prior generation of Lion Cove and Skymont cores. So there wasn't a ton talked about in the slides about the changes. Again, if you want to know more changes, go watch my interview with Stephen Robinson. For the architecture with the most sort of divulgence that most people are interested in is XE3. Now, what's interesting here is that the XE2 and XE3 have the XE core actually share the same compute throughput and supported data types. So yes, there is FP8 dequantization support, but there's no FP8 in the unit. It doesn't support FP8.
Which is weird given how prevalent it's been for AI inference.
FP8 is supported in the NPU, but not in the IGP, which is interesting. Regardless, they have increased the number of threads that a XVE or one of the subunits within an XE core can support up to 10 threads from 8. They have also introduced what Intel's calling variable register allocation. This has been a thing in most GPU architectures since at least 2011, 2010, if not prior to that. What this is if a thread is issued and only needs, say, 32 registers instead of the full 256 registers that it can access, it will only take up 32 of those registers, or 48, or however many registers it needs. Intel did not
Yeah.
have this until XE3. In prior generations, what Intel GPUs would do is they would just, if a thread is issued in Alchemist and before Alchemist, they would just have a block of 128 registers. In Battle Mage, that was changed so that you could either have 128 registers or an option for 256 registers. With XE3, you can now allocate 32 register increments up to 256. So 32, 64, 96, all the way up to 256. There was also some new stuff in the RT units. So some async BVH building, I believe. But that was not talked more on. So I don't know much about that.
So just a headline here. Intel announced 3 SKUs of Panther.
Or
right.
three SKU families.
3 physical implementations of Panther. All 3 have 3 dies. They have a compute die, a CPU, basically a CPU die, an IO die, and a GPU die or tile.
And the other 2 dies are simply structural silicon.
Yeah, so they only have 3 dies with actual transistors on them. The compute die has all of the cores. That's P cores, E cores, and LPU cores. You may remember in Meteor Lake, the LPE cores are on the IO die. They've brought it in because it turns out it's actually more efficient to have the LPE cores on the same die. But as George said, the way that they're saving power is that these LPE cores aren't attached to the L3 cache. So when you only use LPE cores, you don't need to have any of the L3 cache awake. That does cause some memory semantic issues later on because of where your cache stack is. But Intel says they've figured that out. The IO die is always going to be made on N6, and there is 2 GPU tile configurations, one built on Intel, one built on TSMC. The big one is built on TSMC, the small one is built on Intel. And over here on the right-hand side are the 3 configurations. So in terms of P, E, and LPE, we have a 4+8+4 with the big GPU tile called XE3-12 here. The other 2 are the 4 GPU tile with 4+8+4 and 4+0+4. So the E cores are turned off. This does mean, and I've seen a few people point this out actually, this big one, this 4+8+4, is the peak SKU for Panther Lake. This has to go all the way down from low power 15-watt notebooks all the way up to high power desktop. Right?
I don't think this is going to desktop. At least
not
at this point in time. No, this is purely mobile.
Okay, that's my mistake. It's Nova Lake next that's going top to tail.
Yes.
So, but this will still have to be in sort of like the 45, 55, 65 watt notebook.
So what I will say is there was the only power number that was given, you were not there, was during the gaming session. And it was a 45 watt, essentially mini PC, like mini PC.
So a power limited device with power limitations set with power limits.
Yes.
So that number is meaningless. Aside from, here is a lower bound of the upper power limits.
Yeah.
Realistically, I bet you this chip will push to 125.
Sure.
If they really wanted it to.
But my point there is we were not given any actual like TDPs here. So other than that, I can't really say what the power is going to be. Also, something to note on the different platform configurations here. The big GPU and big CPU version and the small CPU and small GPU version share the same platform controller die configuration. So they only have 12 PCIe lanes, 4 Gen 5 and 8 Gen 4. Whereas the sort of middle SKU there, the 4+8+4, and with the smaller iGPU, has 20 lanes, 12 Gen 5 and 8 Gen 4 lanes. I was told that this is the same die for all SKUs, just with different parts turned on and off, depending on where it's going. However, I have heard that maybe there are differences in the platform controller die. So,
well, that might just be a firmware update or something.
I don't know.
So Jay sent us a super chat. Thanks, Jay, for 5, saying they might be abandoning putting P&E cores into the same package, or same chiplet. These are all on the same chiplet, and I've got a feeling that
I know what Jay's talking about. He's talking about the rumored unified core.
No.
That's well into the future.
Yeah, don't deal in potentials. Also, to clear something up, none of these have hyperthreading.
Nope.
What about the AVX10 situation?
No. The ISA is identical to Lunar Lake.
Yeah.
There has been no ISA changes in the cores. As for memory bus, the memory bus is still 128-bit, just like Lunar Lake and Arrow Lake and everything prior to that.
And yeah, to reiterate what George said earlier, even though this is XE3, which should be called Celestial, those names are only for the desktop parts. They have decided to brand the graphics as B series because they are more in line with the performance of B series hardware, even though they have the generational uplift of being XE3, and XE3 desktop cards are likely to be called Celestial. Instead of calling it C series, they're calling it B series. I mean, very few people actually look at the integrated graphics naming, branding. It's like the tertiary thing on the core. It does make it just a little bit annoying because when you try to describe a family, it's essentially the integrated A series or XE1 didn't have a brand properly. XE2 integrated didn't really have a brand properly. And then they came out with something like the A series, and now we just have the B series. It's, yes, you should have architecture base. It looks like somebody at Intel has decided it's better to have a performance base. That would be like the calling the 5080 the 4090.
Yeah. Anyway.
Or 4090 V2. It's yes, and annoyingly, you might think, well, what does this mean for hardware developers? Because they don't know which architecture to target. A proper hardware developer just does chicken bit probing to find out what's actually supported and then work off that. They don't care about the name. Unfortunately, a lot of people will care about the name, but they're not as deep into the architecture as somebody who actually needs to configure for the architecture.
Yeah. Still.
Oh, yes. One other thing before I forget. NPU 5.
Yes.
So latest generation of their NPU. They have, so broad strokes, previous architecture was built on something called DSP and shave units. And what they've done, and it used to be 6 slices. They are now running 3 slices because each slice is now more than double the performance of a single previous gen slice.
Yes.
And the point is that as workloads have evolved, it turns out you don't need as much of the scheduler stuff.
Yeah, you need more map mode, less logic, so to speak.
Less configuration. They're also doing an interesting thing here, in that a lot of machine learning these days, especially attention and token and language model based, you have nonlinear operations such as softmax and ReLU, but also people are looking at highly customized nonlinear functions. And the problem with nonlinear functions is that often it's a complex math which takes space and die area, and so what they've implemented is an internal adjustable lookup table system. So if you pre-compute your nonlinear function once, you now have a bunch of registers to put that data in for a lookup table. Thing is, that's not always ideal because you can't pre-compute every data point. So you have to compute enough and do some linear interpolation, which, given that machine learning is fuzzy, should be fine. But if you actually try to move your model to different hardware, which actually does the computation of the nonlinear function, you'll get a different result.
So,
and Monstercameron has the thing that I've been asking for so freaking long. Why don't they just add a scale-up NPU as an add-in card?
well,
Technically,
Qualcomm's doing that.
that's not an add-in card. That's different. If you want a 6-year-old
Yes, but I'm
sure.
Yeah.
If back when Mavitius was first acquired by Intel, and the first time they put their NPU in a device, I think it was NPU 3 or 3.7. For the embedded market, they did actually build an M.2 card with a chip on. They just never sold it at retail. And I turned round to it was MJ.
They did
at the
sell it
time.
at retail. It was discontinued very quickly.
But you're right. Let's just see if you're gonna. It's AMD, Intel, whoever, Apple, Qualcomm. Just stick your NPU and make it look. But the problem is with that is scale. And as Intel found out with its GPUs, you can't just make a bigger GPU. You can't just take your integrated GPU that typically runs at 10 watts and make the 150 watt version by simply scaling. It turns out some things don't scale linearly, or power doesn't scale linearly. And yeah, so there are a few things. And yes, Intel did make an NPU as an add-in card. That was that the one that was from the Nirvana acquisition?
Yes. And then NNP-I was for Spring Creek.
Crest.
Was it Crest?
Well, so annoyingly, they had NNP-T and NNP-L, but one of the three is renamed from the other one. No, there was an L.
It was an I, not an L.
No, they had both. If you look at the marketing materials, it's really freaking confusing.
Oh. Okay.
Anyway.
Sure.
A little bit off topic. So, I mean, so Panther Lake, the first SKUs out by end of year.
No.
What?
No.
Oh, they've changed.
Officially
that now.
delayed until CES 26. Until with review samples. With review samples with review samples coming later in January, and it should hopefully be on shelves late February, early March.
So Q5 25 then.
Yes.
Yeah.
But anything else you want to say about Panther Lake?
Not really.
Okay.
It's people are going to say, what about AMD and Qualcomm? Well, Qualcomm
they didn't compare it to any of them. So
Qualcomm just announced Snapdragon X2 Elite Extreme Edition, which is 50% more cores, and we still need to find out the details of that. And then AMD's Zen 6 update isn't expected until middle of next year at the earliest, anyway.
Yeah.
So Intel has a free reign with these devices for a few months.
Yes, but moving on to the
I would also say they're also using this heavily in edge and embedded, which is not the part of Nex. It's the other. Anyway.
Yeah. Anyway.
So next up is the day that I missed, technically.
Yeah. So Clearwater Forest, and oh boy, was this slog.
Why? It looks like an amazing part.
eh, So there was at ITT itself, there was very little new revealed. Yeah, what Ian is typing there, we've already known.
Yes.
I think the one new piece of information that came out actually came out in the Intel Foundry talk 2 days before this. And that was that the Foveros technology, the petajoules per bit is 0.05 petajoules per bit for the specific Foveros packaging that Clearwater is using.
You mean
other
picojoules?
Picojoules. Did I say I meant picojoules.
I say petajoules all the time. Petajoules
Yeah.
is 10 to the 24 joules.
Yeah.
It's a small nuclear reactor.
Yeah, very, very different.
So what George is talking about here is because it's 12 chiplets on 3 quads, but each of the quads is packaged with an interposer, and that's the Foveros bit.
No. The Foveros bit is the up and down. It's a 3D.
No, that's what I'm saying.
The EMIB is the.
No, I'm saying the quad connected to the interposer. Is
Foveros. I see.
And the point is, whenever you go off chip to on chip, costs some power, and so if you have high requirements for bandwidth, such as 100 gigabytes per second, or 100 gigabytes per second multiplied by 0.5 picojoules per bit equals 0.4 watts.
Yes.
But it's not 100 gigabytes a second.
No, it's more like per
chip. Per chiplet?
Per chiplet, it's 210. Per compute chiplet, it's 210.
So it's 0.84 watts. Wait, that's 0.0. Sorry, I'll get this right eventually. 84 milliwatts.
Yes, but
80. So that's 8. So 210 gigabyte per sec equals 84 milliwatts.
Yeah. So the new information that was given was, hold on, I have to find this myself. In the ITT presentation was, come on, there we go. Come on, Gmail. Come on.
I mean, generally speaking, Intel. So this is a follow-up E-core product, which was designed for cloud and hyperscalers.
Yeah. So a little bit of history. 30-second history lesson. Earlier this year, Intel, or last year, Intel introduced the 6700E series, or Sapphire Rapids SP, which is the 8-channel 144-core chip. Earlier this year, Intel announced that the big version of that, the 288-core Sierra Forest with 12 channels and 288 cores, will not be going to market as a general product, but will be a product for certain hyperscalers and certain customers. It will be for CSPs. So that will give you some context for why at first what we were given was a performance number compared to the 6780E, or the top SKU of Sierra Forest, which is 144 core at 330 watts. And that uses the older Crestmont architecture, which is found in Meteor Lake and Sierra Forest. The number that was given in ITT was in comparison to a Clearwater Forest 288 core at 500 watts. The increase in performance versus the 6780E was 1.9x the performance, with up to 23% improvement in efficiency. A lot of people, and myself included, said that, stopped and said, wait, where is the comparison to the big Sierra Forest? Because while it technically didn't launch to standard customers, it does exist. I held it in my hand in September of 2024. It exists. It was given out to customers of Intel. So every single person that I talked to went to Intel and went, some louder than others, went, where is that comparison? And so yesterday we got an update, thankfully, and they compared Sierra Forest 288 core at 500 watts, so a hypothetical 6980E, to Darkmont 288 core at 450 watts. Now, why they did make it versus the 500 watts, I don't know. 330, not 350. Again.
Roughly.
Yeah.
What was the Clearwater Forest in this comparison?
Clearwater Forest 288 at 450 watts versus Sierra Forest at 500. The number that Intel said was up to 1.17 higher performance, so 17% higher performance, with up to 1.3 higher performance per watt. This is better in terms of comparison. I would have still have liked to have this been a ISO power comparison, but
did they say what test it was?
They just said based on one socket projections as of date, results may vary. Pre-production projections, 288 core, 450 watt Intel Xeon 6 Plus. By the way, the branding for Clearwater Forest is Intel Xeon 6 Plus.
Yeah. So is what I've written here correct?
Yes.
Yeah. Okay. Yeah. So it's 17%. The thing is, this part here. Yeah. This one here, the first comparison. I'm not sure if you can see the red. Maybe the red's a bad choice. You've got a part at a more efficient point.
Yeah.
The Sierra Forest here is much more efficient point than the 500 watt. And the thing is,
no, other way around.
Well, no, because you're running these per core, your power is higher with Sierra Forest.
Yes.
Yeah, so it's outside of the efficient point, is what I'm saying.
Yeah.
And one of the difficulties here with some of the comparisons sometimes is that the power efficiency changes. As in, do you test at the most optimal efficiency point? In that case, it'll be 800 megahertz or something. And at
it's
0.9
whatever your
volts.
Vmin is, like the highest clock at your Vmin, right?
Yeah. So and often we see performance numbers either peak for peak, but the thing is, the latest generation sometimes pushes the peak a lot further than the peak should be, or the peak was last gen. So there is that. I mean, yeah, it's enterprise CPU coming in first half of 26. But it's the Sierra Forest replacement. Sierra Forest was E-cores, designed for clouds and hyperscalers, designed for ultra light instances. Think web apps where you have to have a separate instance per user, that sort of thing, where you only need one thread and a few gigabytes of memory, but it makes sense to have them all on the same system. The thing is, we saw the same with Bergamo from AMD, and to be honest, even Turin Dense to a little bit, and Sierra Forest, is that these are very specialized processors, right? These are very specialized for a very specific market. So the volumes aren't that much, but it is showing here that at least Intel understands a little bit more, or is showing that it definitely understands a bit more exactly what you need to do with chiplets to make them work, right? Bit too.
Yeah.
The point is chiplets, reuse and recycle, and so they've got 12 chiplets here.
There's the only actual reuse here is the IO dies. The rest of this is currently custom for Clearwater.
No, that's not what I'm saying. I'm saying you've got 12 E-core chiplets. It's one chiplet that's being used 12 times. You're reusing the same chiplet 12 times. Unlike the first Rapids, where it was actually 2 dies but used twice. It's but between products doesn't matter if you've got immense reuse within the same product, right?
Yeah.
And that it's if a customer wants a version that's only got 2 quads, then chances are that will exist at some point.
Well, that will probably exist to drop into as a replacement for the smaller Sierra Forest SKUs.
Yeah. DKR says maybe they can replace it with P-core tiles too. I've got a feeling that the Foveros that would need new IO, new interposer IO, new interposer silicon as well.
Yeah. I don't see that being replaced by P-cores.
Yeah. And besides, there's a P-core product coming, right?
So on that, Intel, there was for Clearwater Forest, there was no further disclosures. Sorry, not Clearwater, for Xeon, which means that we have effectively ran at the limit of what Intel's roadmap.
No, they've showed that. Surely they've showed.
They have not shown anything Xeon 7 or in terms of an actual published slide roadmap.
I see. There's some leaks about next gen.
Yes.
Yeah. Okay. Oh, is it not in the documentation already?
Nope. Sorry, it is in the documentation, but there's no slide for it.
Okay. So a patch in the Linux kernel mailing list confirms that the next family will be called Diamond Rapids.
Yes. And I believe that...
and that's using Panther Cove cores.
Which is not confusing at all. But Lip Bhutan has said Diamond Rapids on an investor call before. But there was no... there was no new published roadmap. Not even
No.
a simple Xeon 7 Diamond Rapids.
It's somebody asked what happened to Intel Innovation. It looks like they've mothballed that event now because it was meant to be next week. 2 weeks after ITT, then they realized, well, hang on, most of the people going to innovation are going to be the same people going to ITT.
So, by the way, I'm about to pick another bone. I know you have a hard stop, but Intel announced that they were going to have a new GPU launching at OCP in less than a week from now. Why didn't you just talk about it at ITT? Come on, guys. Like,
because it's a CPU event. So some more backroom information here. My 10,000 person all hands meeting at Intel was to the DCAI group, and I've seen a couple of people in here have were actually there. So clearly we've got some Intel employees. Now that's not a public, like I said, it's not a public forum. So and part of that is also let's sort of discuss what Intel's doing in terms of its AI strategy, and this has been on the cards for a while. So they did say during the data center day that the new head of the AI group, Sachin Katti, he's taking a different perspective on Intel's AI approach. Not to the extent that there's an extensive roadmap change, but the way they're going to be approaching it is designed to be with a better foundation than it has been in the past. As in
two render slices, Mr. Viptis. PTO's 2 render slices, 6 XE cores each.
It just means Intel's approach to machine learning is going to be a lot more structured than it has been in the past, and that's partly because in the past we had things like Ponte Vecchio, we had this acquisition of Habana and Gaudi and all that stuff, and it's felt too partitioned. And to be honest, Intel's ability to deal with acquisitions at times is questionable, or has been. So we'll see what happens. Yeah, I guess I can stay another 10 minutes, so we should be wrapping up the topics here.
Okay. Quick.
So let's dive into the tech boxes.
Speaking of Qualcomm,
because other people call them tech briefs, and we're men, so we wear boxes. So tech boxes.
Yeah,
it's a dumb thing, but
Qualcomm buys Arduino. Yeah, that was not what I was expecting.
Arduino. You said you made the mistake I did.
It's Arduino. I don't care.
So Qualcomm's GPU architecture is called Arduino.
Yes.
And this is Arduino or Arduino.
Arduino.
Arduino are the famous. They brought easy to use microcontrollers to the edge embedded and homebrew space. And it's people don't know, but it's actually a really small company. I think there's something like 200 employees, but 33 million active users. They're announcing a new chip as well as part of this arrangement. And they had a live stream the other day that I missed. I don't think the amount of money's been mentioned, but the whole point here is Qualcomm is actively in the embedded space anyway. Just check my notes here. Yeah. Arduino's revenue in 2024 was just shy of $50 million US, which is going up, but it's still not a massive amount. I saw on another podcast they listed something like 1 to 2 million units a year, but they have specialized models that can hit 250,000 units in a year. Yeah, there's a new chip launch, and there's two sides here, right? Arduino has always been considered small and scrappy, right?
Mm-hmm.
As in, it's what you. Okay, my system is deciding to crash slowly. It's something that you use. Yeah, if you want to do a homebrew stuff, if you're doing breadboard stuff, it's designed to be cheap. It's designed to be expandable. You've got all these I/O pins, analog power, and all the other sorts of stuff, and really get people into electronics. But again, it's been rough and ready. So one of the positive points of view for this coming out is, well, Qualcomm knows how to build a B2B ecosystem. And Arduino's B2B credentials haven't necessarily been the best over the years and could have been a lot better. So this is a chance to join Qualcomm's moving train of B2B design. Thing is, that also acts like a double-edged sword a little bit, because Arduino is known as the scrappy one. The open source ethos and the brand and the mission, just to quote a few words from this slide here. And the fear is that Qualcomm will turn it too corporate, and which all of that may entail. The idea, but Qualcomm's argument is here: let's empower businesses and students. Let's get it into the hands of 10 million people a year, not 2 million.
Also, Arduino has sort of been under significant pressure from the ESP32 family as of late. Dom says if Arduino didn't have their IDE as polished as it was, it would have been over a lot sooner for Arduino, and I do kind of agree.
Arduino has good software for being the scrappy company it is. One argument here is that it might actually help Qualcomm's other businesses.
I wouldn't be surprised, but it would be nice to start seeing if Qualcomm decides to really push this, see sort of more features in this ecosystem. But I think we've covered this. You can go read the press release if you want. This next piece of text box. This next boxer is really funny. So, SiPearl, the EU startup to build EU sovereign chips. SiPearl, launch of Athena 1, the sovereign processor dedicated to dual use. A bespoke version of Rhea 1 to meet the specific requirements of government, defense, and aerospace sectors in terms of computing power, security, and integrity with a reduced carbon footprint.
So George and I had a good laugh when we saw this.
Yes,
because we've kind of pooped upon it from a height on the SiPearl Rhea 1, because it is a Neoverse V1 chip launched in 2025, an architecture that was announced back in 2019.
Yes, technically they're shipping until next year, so there's a 7-year gap.
Yeah, and right now when NVIDIA is shipping Neoverse V3 en masse. Now, don't get me wrong, SiPearl is still a startup. They've raised 100 million or 150 million euros, that sort of thing. And they're currently going through a Series C right now. The whole idea of SiPearl is let's make as far as we can, EU-based sovereign processor. And Rhea 1, bunch of Neoverse V1 cores with with HBM on package. So it's a HBM-enabled CPU. So it's A64FX or Xeon Phi or something of that ilk, or Xeon Max. Sorry,
it's a HPC. It's for HPC.
Yeah, and they've already won a few contracts with this, right? Again, European supercomputer sort of thing. So now then, talking about Rhea 1, a specific design. Rhea 1 removes the HBM.
Athena 1.
Athena 1 removes the HBM, leaves it 4 DDR5 channels, comes in a variety of SKUs, 16 to 80, which George and I think it's just the single die from 80 cut down, as in bits turned off. It's built on TSMC N6. The commercial release of Athena is the second half of 27.
This is honestly very, very funny. So mind you, Rare 1, right? Rare 1 has about, they were saying about 1 terabyte of memory bandwidth.
So
Rare
4
1
HBM2E stacks.
Yes, is coming out at about the same time as AMD Venice, which has 1.6 terabytes of memory bandwidth. This is coming out. This is coming out in second half of 27, closer to Zen 7 than to Zen 6, and this has 4 DDR5 controllers at who knows what speed.
Well, DDR5 4800 would mean what, 220 gigasec?
If it was 6400, it would be 204.
Yeah. And I'm pretty sure we have mobile chips that are hitting that value now.
Yeah.
Or the Snapdragon X2 Elite.
Hold on. Let me just move real quick. Yeah, that laptop has more memory bandwidth.
Yeah, and which sounds absolutely silly for a processor that's using cores 7.5 years after they were announced.
Yes.
Yeah, we just wanted to highlight this just because it. Okay, here's an overarching question, right? If you were to order, and I don't know what the metric is, SiPearl and Tachyon. Does SiPearl get kudos for having silicon, but then gets cut back because it's 7.5-year-old cores?
I mean, I'll be honest. So the next big event that I'm going to is supercomputing. Both SiPearl and Tachyon will be there.
Fight.
Oh, I have plans, Ian.
No. I don't mean between SiPearl and Tachyon. I mean between George and Tachyon.
Yeah. Oh,
George and
like
SiPearl.
I said, there will be plans.
So.
Also, just a quick shout out to anyone who will be there. November 16th, there will be a CNC gathering at a restaurant. Can't remember the name at the top of my head at the moment. It is called.
So that's St. Louis. It's it's St. Louis, Missouri.
Yeah, Sugar Fire Smokehouse. For people that want to join.
It's going to be SWAT raided now. You've told everyone.
True, but
and with that, I am going to have to leave. My time is up, unfortunately.
Yep.
But yeah, no, there's a wild bunch of stuff going on. There definitely won't be a Poutine next week, but there will be a bunch of stuff the week after, which we are going to have to talk about. So that's going to be fun. I'll tell you offline.
Okay.
Awesome.
Anyway, this has been fun. I'll let you answer
Henry did send us a $5 super chat. Do you think Tesla is going to be able to remove the safe driver from their robotaxis this year? No. And that's regulation. Even if the hardware was up to it, regulation is years behind. So, but thank you for that. And thank you to everyone for joining and for such short notice. Yeah, okay. Awesome. Cheers, guys.
Good one, folks.
We'll catch you on the next one. If you like this content, there are multiple ways to support the channel. You can like and subscribe this video, and many thanks for doing so. There's also Patreon, which gives you access to our Discord. There's a merchandise store and a newsletter, links in the description. For all of you who do contribute, thank you. You are keeping me well fed.